All right, let's go ahead and try a question on profit maximization from the spring 2013 midterm 2. So as always, as we walk through the question, I'll show you how I'm parsing the information, any choices I'm making along the way as I go about doing the solution. So let's jump into it. All right, a farmer uses soil S and fertilizer F to grow zucchini Z. All right, so just a little note to myself here, Z is our output, right? Soil, fertilizer are inputs. I'm just going to write that down in our standard production function notation just so I can keep track of it. Okay? The amount zucchini a farmer can grow is given by the following production function. All right, so we're actually told the production function here. Z is equal to 10S plus 4F to the 1/2. All right, now we're given some prices. The price of a unit of soil is 5. Okay, so I'm going to keep track of that. PS is equal to 5. Price of unit fertilizer is 2, so PF is equal to 2. Market price for unit zucchini is 10, so PZ is equal to 10. All right, just writing those off to the side so I don't have to wade back into all of that text. Okay, so let's go ahead and get started with part A then. Find expressions for the marginal product of soil, the marginal product of fertilizer, and the technical rate of substitution. Your expression for the technical rate of substitution should correspond to the slope of an isoquant on a graph with fertilizer on the horizontal and soil on the vertical. All right, so let's just do that really quickly on the side here. So fertilizer on the horizontal, soil on the vertical, just so that we can make certain we keep that straight. Okay, so let's start getting these marginal products. So let's start with the marginal product of soil. So MPS going to be the derivative of the production function with respect to S. And so when I look up at my production function here, the first term I've got 10S, so I take the derivative, it'll just be 10. My second term have no S's in it, so it's going to disappear when I take the derivative. So that is my marginal product of S. Okay, so now my marginal product of F, derivative of the production function with respect to F. Okay. Now my first term doesn't have F in it. That's going to disappear when I take the derivative. Second term, I'm going to bring down the exponent, still have my constant out front, and then I'm going to lower the exponent of F by 1. Okay. So simplifying that slightly, that's just 2F to the minus 1/2. All right, so we've got our two marginal products. Now it's time to do our technical rate of substitution. Here's where we have to remember which good or which input's on which axis. And thankfully, I gave myself a really quick way to see it over here instead of having to go back to the question, right? F's on the horizontal. That means we put the marginal product of F in the numerator, marginal product of S in the denominator here when we set this up. And so that's going to be minus marginal product of fertilizer is 2F to the minus 1/2. Marginal product of S was just 10. So the 2 over 10 is going to give me a 1 over 5. And I'm going to move my F to the denominator just so I can get rid of the negative exponent, make it positive. Right? So there we go. We've got our marginal products. We've got our technical rate of substitution. Time for part B. Suppose in the short run, the farmer has 50 units of soil, right? So S is equal to 50, and it's fixed, right? He's unable to buy any more for the season. So I'm just putting a little bar over the S so that I remember that's fixed. The farmer can buy any amount of fertilizer he wants, so F is variable here. If the farmer's maximizing profits, how much fertilizer will the farmer use and what profits will the farmer make? Okay, so here we're in a short run situation because one of our inputs is fixed, the other is variable. Right? And so really we're just deciding, well, how much fertilizer should we use? Right? Well, here is where we want to think about what it costs to get an extra unit of fertilizer, which is PF, right? We're willing to pay that as long as that's less than what the fertilizer generates for us in revenue, right? So the revenue is whatever the price of zucchini is times how much zucchini that extra unit of fertilizer gets us, right? So the marginal product of fertilizer is the extra zucchini we're going to get from more unit of fertilizer, multiplied by the price of zucchini, that's the revenue we get, right? The cost of that unit of fertilizer is just PF. If PF was smaller than this thing on the right, we should use more fertilizer. We'll make more money. If PF was bigger, the last unit of fertilizer didn't cover its costs, so we shouldn't have used it. So we're going to use it up to the point where this is true. Okay? All right, so now it's time to just plug in. So looking up here, up here, I had PF is 2. I had PZ was 10. And coming back to here, I had my marginal product of fertilizer was 2F to the minus 1/2. Okay? So those 2's are going to cancel, right? I'm going to move my F to the 1/2 over to the side, so that it becomes an F to the positive 1/2 is equal to 10. That's just going to give me F is equal to 100 when I square both sides. So that's the amount of fertilizer that I'm going to use. And now I still need to figure out what are the profits going to be, right? Well, so for profits, that's going to be the price of zucchini times however much zucchini I can make, which is what I get when I plug in my 50 units of soil and my 100 units of fertilizer into my production function. And then I have to subtract off my costs, right? Which is going to be my soil costs and my fertilizer costs, right? So plugging in numbers for everything here, we got the price of zucchini was 10. We've got our production function. It's way back up at the top. It's 10 times S, so 10 times 50, plus 4 times F to the 1/2, so 4 times 100 to the 1/2. Right? And then our price of soil, we go way back up here, was 5. Our units of soil is 50, so it's going to be minus 5 times 50, minus our price of fertilizer was 2, and we're using 100 units, so minus 2 times 100. All right, so what is this big mess going to be? This is going to be 10 times 500 plus 4 times 10, so 540. So that's going to be 5,400 minus 250 minus another 200. Right? And so all of that, get that on screen. So we've got 5,400 minus 450, right? That's going to give me 4,950 as my overall profits. Right? So there we go. If you didn't want to do that math, you could leave it at this point where you just plugged in numbers, right? As far as grading is concerned, no difference between leaving it as this line, or this line, right? But I do want to see that you plugged in the appropriate prices and quantities. Okay. So now we move on to part C here. Suppose instead that the farmer has 100 units of fertilizer and cannot purchase any more this season. The farmer can purchase as much soil as he wants. If the farmer is maximizing profits, how much soil will the farmer want to use in the short run? Be certain to fully justify your answer. Okay. All right. Little test-taking note here. The previous question didn't ask us about fully justifying our answer. This question did. That makes me suspect that there's going to be something a little strange going on with this answer. Right. So let's start thinking about it. So in this part C, right, what's different is that fertilizer is fixed at 100, right? And S is variable. So what do we want to do? Well, we could try doing the same thing as before, where we say, set the price of the variable input equal to its marginal product times the price of the output, right? Apologies for the coughs here. So if we go back to our little set of notes over here, price of soil is 5, price of zucchini was 10, right? Marginal product of soil, if we go back to part A, was 10. And what we've got is 5 is equal to 100, which is obviously not true, okay? But what does that mean? Right? Well, that means that every extra unit of soil we buy costs less than what it's generating in revenue, right? Every extra unit of soil we buy is 5, but it generates $100 in revenue for us. So we're making $95 in profit on each one of those units, right? And so given that, right, we're going to want to buy all the soil we can, right? And so to explain that, right, I'm going to say, since MPS is constant, and PS is less than PZ MPS, every unit of soil makes profit. So you will buy all the soil you can. All right, part C done. Okay, so moving on to part D. Now consider the long run in which both soil and fertilizer are variable inputs. Derive expressions for the amount of fertilizer the farmer will use as a function of zucchini and the amount of soil the farmer will use as a function of zucchini. Note, you can assume the farmer is only considering producing large quantities of zucchini, so Z greater than 100. That little note is just a little side product of the oddity of having one of these quasi-linear functions. You don't need to worry about that. Okay. So, in the long run, what are we going to do, right? Well, we want to switch between our inputs, right, to balance them out so that they're kind of equally productive in terms of spending an extra dollar on each one, right? So another way of saying that is that if we go back to how we were doing our graph earlier with S and F as our two vertical axes, right, we want to set that technical rate of substitution, that marginal product of F over that marginal product of S, right? We want to set that equal to the ratio of the prices of those inputs, the price of F over the price of S. Right, so this on the left, technical rate of substitution, slope of the isoquant, right? This on the right, the ratio of prices to the inputs, that's the slope of those isocost lines. So we already found the left-hand side way back in part A, right? So that was 1 over 5F to the 1/2, okay? As far as our right-hand side goes, well, here we can go back to our handy little set of prices over here. Right? That's going to be PF over PS, so that's going to be 2 over 5. Okay? So simplifying this is going to be moving the 5 and the 1/2 over there. Okay? Those 5s cancel. My 2 is going to end up in the denominator on the left-hand side. My F to the 1/2 is going to end up on the right-hand side. And when I square both of those, right, I just get 1/4 is equal to F, all right? All right, little unusual here that the other input isn't still in this expression. That goes back to this being one of these strange quasi-linear functions. So what I can do now is I can plug this into my production function. Right, so I'm going to take that result. I'm going to use an arrow to help whoever's grading this know my workflow so I can get all the partial credit I can, right? And I'm going to say that Z is equal to, we're going to go back, polar function from earlier. Z is equal to 10S plus 4F to the 1/2, but I'm going to plug that in for 4F to the 1/2. Right, so F is 1/4, that's getting raised to the 1/2. So now I've got that Z is equal to 10S plus 4 divided by 2, which is just 2, right? So what I'm trying to solve for here is S. So I'm going to say 10S, I'm going to move my 2 to the other side, so that's going to be Z minus 2. Then I'm just going to divide everything by 10. So S is equal to 1 over 10Z minus 2 over 10, which is just 1 over 5. that is my final expression for s as a function of z, right? And my expression for f as a function of z was just that 1/4, right? It actually doesn't depend on what z is. Okay? And so there's my final answer for part D. So, yep. All right.